cell phone data network. You're basically on the internet. Telco and network proxies, and commercial services offered by vendors. So, you know, commercial SIP. One thing that's really important to remember, I don't know what the legislation is on this side of the pond, but certainly in North America, if you have voice over IP termination for regular, like for a phone number, so not sort of the voice over IP to voice over IP services like free world dial-up, but if you have something like, I'm trying to think of provider names, but anyway, you have some sort of SIP or IX, any of that PSTN termination, they are legally obliged to conform to the same lawful interception laws as any telco is. They may not have complied yet because they just might not have built their infrastructure to do that yet, but CALEA legislation in the States and the equivalent in Canada, it's all on the books. It's just that they haven't started enforcing it in all cases yet. But it will come, and it will come soon. So just because you're going from voice over IP to your personal asterisk server in your house to your voice over IP phone in your house, don't think that you're not subject to legal interception.
Actually, in Europe, there's already the ATSI standards and the transport over intercepted IP traffic. So there's already standards to do internet tapping. And if you move from voice to VoIP, basically you're just moving into another realm of tapping. But all the laws there and all the most of the infrastructure is there now as well. Like Siemens is one of the big German vendors for interception capabilities in various telecom equipment, including everything that can do voice. VoIP.
Ironic that. So we've gone over all the things that you can't trust. So what can you trust? Well, the only thing you can really trust in this case is stuff that you've rolled your own of. So your open source OS on the phone, we'll get into the trials and tribulations of that shortly, your own open source PBX and VPN and IAM servers, and your own open source applications for each of those services on the phone, whether it's SIP or IX or another voice over IP protocol. Your own VPN, whether it's OpenSwan, IPsec, another IPsec implementation, OpenVPN, and then IAM applications. One thing that's really important to remember about IAM applications, we're not talking MSN, Messenger, or AIM, or Yahoo, because those are all going through a central server. It's got to be something like Jabber that is a non-centralized instant messaging system, because otherwise you're just defeating the whole purpose by having a plain text connection to somebody else's server. So, and yeah, refusing to use a fallback, you know, having your own trusted infrastructure. If this is an absolute must that you have to have this secure communication, don't use a fallback because you open yourself up. So the problems of running our own PBX server, you can't really hook it up to traditional phone line or even, as I said, a commercial SIP or IX to POTS provider. Just for, in case anybody isn't clear on those acronyms, PSTN, POTS, they mean the same thing. They mean landlines or cell phones. Plain old telephone system, publicly switched telephone network. Probably all knew that though. It's pretty impossible to secure complex VoIP products natively. The basic overall recommendation from the major vendors, from the IETF with regards to SIP, from the people who wrote IX, is the best way to secure this is to put it over VPN. You know, you can do a couple of different things. There's authentication for both the SIP and the IX protocols, but you want to put it over VPN because these authentication protocols are not intended to do peer-to-peer authentication. They're intended as a server-to-endpoint infrastructure using certificates and like that style of authentication. They're not intended for me calling someone on a SIP client or an IX client and there being encryption there. You want to trunk it over a VPN. The other problems that you run into when you're running a VoIP server are information leakage via VoIP. You've got your presence status that can be seen using SIP. You have stuff like directory harvesting attacks that are sort of, it's basically the same thing as having finger running on a mail server. Somebody can just run through every possible name and find all of the email addresses, find all of the SIP extensions or IX extensions. You're storing lots of sensitive information on that PBX, like voicemails. I don't know how, like, I've never quite understood why people get so worked up about voicemails, but I know that in a lot of industries, people save their voicemails ridiculously. Like you get transitioning old PBXs over to new ones, and people have hundreds of voicemails saved in their mailboxes, and they're like, it's a really serious emotional attachment to these voicemails for some reason. And then you get lots of bogus incoming information. There's a huge problem with insecure PBXs, voice over IP PBXs in particular, and so there's a lot of scanning that goes on. So if you are running a PBX that is in any way identifiable as a PBX from the internet, even if it's completely locked down, you're still going to get a lot of garbage information thrown at you. And a lot of garbage calls, although that, it's picking up slowly. The spit problem, it's not a huge problem yet, but it will be. It totally will be. And yeah, that's the IETF's recommendation, wrap your VoIP protocols in VPNs, and a lot of people seem to be following that, but there's a number of fun and challenging Google hacks involving like Cisco PBXs on the internet. So. Problems of running a secure phone. This is sort of the flip side of the coin to running a secure PBX. You've got an unknown piece of hardware with potential backdoors. Even if you're running an open source phone, we'll go into this later. There's the standard configuration for an open source or Linux-based cell phone is to have two processors. One processor is running the Linux OS, and the other processor is running some mystery unknown embedded OS. And the Linux part of the phone, the Linux processor or process, has serial access to things like the radio and the GPS and the microphone often. And then there's this closed proprietary OS that has the actual access to the hardware. This is done for fairly reasonable reasons, in that there are regulatory issues around cell phone power and output and interference with other phones, that kind of thing. So that's why they're doing the closed, the embedded part and then the separate OS level part that you have access to. So again, as we said, there's no free access to the hardware. Then you get stuff like the OS just being vulnerable if you don't know what it is or if it's Windows Mobile. You have the whole separate issue of the portability of a cell phone, which is part of its usefulness, but also a bit of a danger when you have that phone stolen from you and now somebody has access to your whole address book, all of your information, and the ability to make calls as you. So don't store your pins in a speed dial or anything. It's just your voicemail pin in a speed dial. My dad did this once. I got really mad at him. Anyway, you have unknown and untrusted voice over IP applications running on this phone if you're using it as a Wi-Fi phone or whatever. There's not a lot of them out there, but you can run SIP on your Windows Mobile PDA, and that's sort of what we're talking about there. So do you want to take over for a bit?
So now we talked a bit about the PBX system and a bit about the phone. Now about the layer in between, which is the connectivity. There's different ways you'd want to have your phone connect to a network. And of course, ideally you want a high-speed network, and if that's not available, you'll fall back to a lower speed one. And actually, this phone is like a dual phone. It's got GSM, but it also got Wi-Fi. So if the Wi-Fi here is up, somebody can actually call this phone. The Wi-Fi hasn't really been up today much, I noticed, so this phone's unavailable, but it also has a GSM, so you can call it on its other number, and then it's just a normal GSM phone. So what are we looking at? We have Wi-Fi and WiMAX, which if it's available will be your best bet. It's got high bandwidth, low latency. It tends not to be too mobile. If you walk away, you can't reach your neighbor's network anymore, or your own network anymore. Hopping between networks is often not as reliable either. If you go from one access point to the other, even if they're set up to be one big network, it doesn't always work.
Hopping between networks with a voice over IP connection is so flaky as to be impossible. It's just not even worth trying.
Yeah, remember, if reconnecting takes you 1 or 2 seconds, your conversation will be severely interrupted. We're hoping to get some more data later when Toronto Hydro fixes their network, so we can actually do something with it. But at this point, like Toronto Hydro has basically rolled out a complete one big, large, I think 5 by 3 kilometer network in the downtown area. So basically the whole downtown area is now covered in Wi-Fi, except you can't even use a web browser on it, so I'm not even trying the phone yet. It's pretty broken. And so far there aren't that many phones that actually have Wi-Fi. It's beginning to show up in the newer XDAs, which are way too expensive, but in other phones. So maybe one of these new Linux-based phones will be cheap enough to actually have Wi-Fi. So if you do that, then you're not using the telco. The telco is pretty expensive anyway, so if you can get free Wi-Fi from the air, that's preferable anyway. Your fallback option will be GPRS or the successor of GPRS called Edge, which is supported on the newer phones. The bandwidth is pretty low, the latency is pretty high, and I must say, I haven't used GPRS in the last, I think half year or year or so. But when I was using it, a year ago in Amsterdam, it was pretty bad. Even just running SSH was pretty impossible. Of course, with SSH, you have the problem it's very interactive. You hit a key, it sends a packet, it waits for a packet to come back. When you hit another key, so the latency really eats you up there. So GPRS is not the best, but it's doable. I'll show some graphs in a bit, where we can see that it is doable, even though it's not ideal. UMTS is not that different from GPRS, except you get more bandwidth, but really we don't need more bandwidth. The bandwidth is sort of enough if you go with a lower codec. So sure, with UMTS you could use a better codecs, but you still have the high latency problem. What the Cryptophone has done to solve this problem is that they're actually making a modem call, like an old-fashioned voice call, and then you hook this acoustic coupler on the line, and you make it turn into a digital signal. So they're doing a voice call, so they're getting their guaranteed bandwidth over that. So it's low latency and. I stand corrected. Okay, but you do get a dedicated slot, unlike GPRS, right?
And it's not on the offsite.
Okay, we will fix these slides. The Cryptophone's cool. So if we look at GPRS, the theoretical bandwidth is about 40K down and 30K up. One of the problems of the telco and IEEE in general versus the IETF is that the telcos have decided that they need to do a guaranteed delivery. So if some packet transmission is lost, they will keep the packet, and because they actually also want a in-order guaranteed delivery, they will keep all the other packets they already have until they can resend that one packet, and then they will resend everything else. This is completely different from how the internet works. The internet basically works if we send a packet, and if the other end cares and missed it, then they'll let us know and we'll resend it. And if this happens, if it's going okay, then we'll send some larger packets, or we'll send packets faster. And if we get more dropouts, then we'll slow down again. So this whole dynamic bandwidth sending that the internet is using works much better than this guaranteed in-order delivery where you're stalling. If I'm talking over, if I'm doing a voice conversation with somebody and I've dropped a few packets, I'd rather have that they miss one word than that they're stalled for 15 seconds and then have all these retransmitted packets and hear the same word every time. So death to OSI, yeah.
Important thing, we're talking a lot of packets here. There's been a number of problems with the Linksys WRT routers that everybody loves to load firmware on, where you tried to put a SIP connection over one of these routers and it would reboot the router because it just couldn't handle the number of packets you're trying to send. So this, that's the guaranteed in order delivery thing is a huge problem for what we're trying to do.
So having that problem, if we're using UDP like OpenVPN or IPsec, which is sending ESP packets, we'll get these duplicate packets because they will be sent. The upper layer will assume that they're dropped and you might resend them. And they will also be resent by the telco network. So we'll get multiple layers trying to resync the connection which is like really horrible for your performance. It gets even worse when you're using TCP, because you get the whole TCP handshaking and SYN-ACK packets.